All right, we'll wrap today up with a little homework help. And this one is very similar to what you'll be doing for homework 1531, same picture and everything. But I want you to think of this one. We've done very similar ones using work and energy, using rectangular coordinates with force equals mass times acceleration. We've got another option now. We can do this type of problem using momentum, and it's really pretty simple. So we've got block A going to the right, block B going down with their respective weights. And it says if B is going down with a velocity of 3 feet per second, right, that must mean this one is going twice as fast because it would pull with half the weight to move this up, right? So if it is going 3 feet per second at t equals 0 and the velocity of A is what we want to find at t equals 1 second, and they give us friction for block A, 0.15. And what we need to find is the velocity of block A after 1 second. So let's think about that. How can we do this using momentum? It's kind of an interesting way to approach it, but it's definitely an elegant method. So we could say they're both starting from rest, right? Or no, they're not starting from rest. They're both starting from 3 feet per second for this mass times velocity and 6 feet per second for block A if it's necessarily moving twice as fast as block B. We know their masses, so we could figure out each block's momentum, their mass times velocity, right? And that's what I was doing there. So um, we could set up our equation and say, okay, if I have the 10-pound block, which was block A, right? It's 10 over 32.2. That's its mass in slugs, right? 10 pounds divided by gravity times 2 times 3. That was to make this twice as fast as block B, right? So it's going 6 um, feet per second. Make sure my units are right here. So we've got 6 feet per second times its mass. And I've made that negative here, basically to just be the opposite of what this one does, right? They've drawn this going that way. And so we want to make sure that they're opposing each other as far as momentums go. And then we've got the forces that are going to change the mass the momentum there. So I've got the t times 1 second, whatever t pulling on that. And then I've got the 0.15 times 10, also times 1 second that they're not showing here, right? But that would be our friction force also acting over 1 second. So those are our two forces acting on it, equals the final momentum of A, which would be the mass again, velocity 2. Okay. So that is our final velocity. We'll find out if that's going to be positive or negative. And then we can set it up for the block. Yeah, this is block B, where we have the 3-pound, which is block B, divided by gravity. So there's the mass in slugs. It was originally going 3 feet per second. And we've got a -3 times 1. So that is going to be its own weight, pulling it down for 1 second. And it has two t's also acting on it. Oop, too far. Over the course of 1 second. And so its final mass times velocity will be the same mass again in slugs. And the velocity of A divided by 2 is the way that they're handling this. The velocity of A divided by 2. That's a little bit funny, but we don't know what velocity of B2 is. We just know that it is half of whatever velocity A is. And so between those two equations, you can solve for the second velocity of A, which would be 6 feet per second. I would coincidentally give you the velocity of B being half of that, right? Which is interesting. If A started at 3 feet per second, now it's going 6 feet per second after 1 second to the right. And I think the confusing part about this might be the signs. Right? They've basically said to the right is negative for A because they said downward was positive for B. But since that was the given info, 3 feet per second, they called that positive and used that for everything. So just make sure you've figured out which way your signs are. Just make those all consistent so that, whatever force is fighting this or making it move in one direction, or the friction fighting that motion, right? Those needed to be opposite of each other. And that just needed to agree with the direction that we made block B be moving. Okay, so try that out in the homework. That's pretty similar, like I said, to the one that you'll do, 1531. And that'll be some good practice trying out this new method using momentum, a very nice and elegant way of handling velocities again.